Hello everyone, welcome back to my channel Study Motivators. Today I am going to solve one more problem related to the post tension beam. Okay, before going to solve the problem, please do like, share and subscribe to my channel. This is problem number 3. A post tensioned pre-stressed concrete T section having flange width of 1200 mm and flange thickness is 200 mm. Okay, so solution. BF equal to 1200 mm and TF equal to 200 mm. Okay, BF means width of the flange and TF means thickness of the flange. Okay, and thickness of the web is 300 mm, means BW equal to 300 mm is pre-stressed by 2000 mm square of high tensile steel is located at the depth of 1600 mm. Okay, means if pre-stressed by 2000 mm square means area AP equal to 2000 mm square. Okay, then is located at depth of 1600 mm means small d equal to 1600 mm. Okay, if FCK value is 40 Newton per mm square, FCK equal to 40 Newton per mm square, then FP is 1600 Newton per mm square, FP equal to 1600 Newton per mm square. Then find the flexure strength of the beam, means M equal to question mark, and L by D ratio is 20 mm, L by D ratio equal to 20 mm and FP value is 1000 Newton per mm square. Okay, this is given data. Now draw the figure. This is T beam. This portion is called as flange portion and this portion called as web portion. Okay, and flange width is BF equal to 1200 mm and thickness of the flange is TF equal to 200 mm. Then BW, width of web equal to 300 mm. Okay, then AP is 2000 mm square, area is located here in this T beam, so AP equal to 2000 mm square. Then D, effective depth, D equal to 1600 mm. Okay, and this is given here. Now find the flexure strength of the beam, means formula M equal to FPU into AP into bracket open D minus 0.42 into XU. Okay, this is formula for finding the flexure strength of the beam. Now beam is given question. First find these two condition. Okay, condition number 1, if XU is less than TF means neutral axis is less than thickness of the flange, then it is considered as a neutral axis is within the flange position. Okay, if neutral axis is within the flange position, then area value is directly taken for finding the flexure strength of the beam. Okay, if XU is greater than TF, then it is considered as a neutral axis within web position. Okay, then recalculate the area value. Okay, this is two condition is important. Okay, now step number 1, let us calculate the effective reinforcement ratio. Okay, so formula is AP into FPE divided by BF into D into FCK. Okay, this is formula. Now AP values given question 2000 into FP value is also given question 1000 divided by BF means width of the flange is also given question 1200 into D is 1600 into FCK value is 40 Newton per mm square, and now we got answer as a 0.026. Okay, now from table 12 page 52 IS 1343 2012. Okay, now we want FPU divided by FPE value and XU by D value for corresponding L by D ratio is 20 mm. Okay, now we got AP into FP divided by BD into FCK value is 0.026. okay, here we don't know 0.026 corresponding value. Okay, now with the help of the interpolation we finding the 0.026 corresponding value. Okay, so 0.025 corresponding value is 1.34. okay, and 0.05 corresponding value is 1.32. okay, so 0.025 corresponding value is 1.34. now we want 0.026 corresponding value. okay, so 0.05 corresponding value is 1.32. now with the help of the interpolation we finding the 0.026 corresponding value. okay, so now 1.34 plus bracket open this value minus this value, so 1.32 minus 1.34 divided by this value minus this value 0.05 minus 0.05. okay, bracket close into again bracket open. So now we want 0.026 corresponding value, so 0.026 minus this value. okay, 0.025. okay, now we got answer as a 0.34. so now we got FPU divided by FPE equal to 1.34. okay, so 0.026 corresponding value is 1.34. okay, now we want FPU value, so FPU equal to cross multiplication, so FPE into 1.34. okay, so FPE value is given in question 1000 into 1.34. so now we got FPU value as a 1340 Newton per mm square. okay, similarly we find XU by D value. okay, again from table now we want XU by D value. okay, so 0.025 corresponding value is 0.10 and 0.05 corresponding value is 0.16. okay, so so 0.05 corresponding value is 0.10. now we 0.025. okay, now we want 0.026 corresponding value, so question mark, so and 0.025 corresponding value is 0.16. okay, again with the help of the interpolation we find the 0.026 corresponding value, so 0.026 plus so 0.10 plus bracket open this value minus this value 0.16 minus 0.10 divided by this value minus this value, so 0.05 minus 0.25 bracket close into this value minus this value, so 0.026 minus 0.025 bracket close. Okay, now we got answer as a 0.10. So we got xu by d value as a 0.10. Okay, we want xu value. So x is equal to, again cross multiplication, d into 0.10. So d is given in question 1600. Okay, so 1600 into 0.10. Now we got xu value as a 160 mm. Okay, so xu value is less than tf value, means tf value is 200 mm, means it is first condition. Okay, now not necessary to find the area value. Okay, so tf is, so xu is less than tf. Okay, tf is 200 mm, so xu is less than tf. Okay, 160 mm is less than 200 mm. Okay, now neutral axis is within flange position. Okay, then step number 2, find the flexure strength of beam. So formula m equal to fpv into ap into bracket open d minus 0.42 into xu. Okay, so fpu value is 1340. Okay, so 1340 into ap value is given in question 2000 into d value is 1600 minus 0.42 into xu value is 160 mm. Okay, now we got final value as a 4107.9 into 10 raised to 6 Newton mm, or 4107.9 kilonewton meter. Okay, this is the final answer.